So, hello friends, welcome back to another session with Learn My Classes, Learn Easily with Maths. So, as you can see today, our topic for the day is division of algebraic expressions. We've been doing this series. I had earlier done addition and subtraction of algebraic expressions. Then we went on to multiplication of algebraic expressions, and all this you can actually access very easily on my YouTube channel, and it goes by the same name, which is Learn My Classes. So you can have a look at it on the Insta or on my YouTube channel, right? So let's progress with the topic, and the topic, as I said, is going to be division. Now, division, you've been learning since, I guess, the first time you ever touched division would have been in class 2. When you went into two-step division, it was class 3. So you did it very, like, it just came very naturally to you. Let's just go back to that same division and see what were the things you actually could take from that division, which we are going to be using in algebraic division, right? So let's just say previous knowledge, you should be having a fair knowledge of division of numbers. So let's say a very, very basic example. I'm going to try and divide 629 by 13. So let's do that. I put 629 as my dividend. I divide by 13. Now, how many times does 13 go in the first two digits? It goes 2 times to give you a 52. Sorry, 4 times, and so that is 52. So, how did I get 52 here? This is simply a multiplication of this and this, and with each step, what are we trying to do? We are trying to reduce the balance which is there in the dividend. Sometimes it will come to 0. And what did we do next? We subtracted it. So, one thing which I have just told you, how did we write that 52? It was a product of the quotient and this part of the divisor. So, that is how you got your 52. And you have to subtract. So, this is what you are going to be keeping in mind even when we do your algebraic division. So, when I subtracted, what did you get? You get 62 minus 52 is going to give you a 1, 0, and you have a 9 here. Now, in 109, if you look at your table of 13, 13, 8 is 104, and so you're going to be giving 8 here, and again, 8 13s are this number, 108 is going to be written here. Again, my effort is to try and reduce the dividend to get a 0 remainder if possible. Sorry, 104. So, I get my remainder of 5. So, what did we learn? 2, 3 things. The number subtracted is the product of the quotient digit and the divisor, and it has to be subtracted. How do I subtract? By putting a negative sign. It has to be subtracted a negative sign. So that was my first takeaway, your second takeaway, and the third takeaway. Did you notice that the remainder is less than the divisor? So the third takeaway is that the remainder is less than the divisor. So these 3 things we are going to keep in mind even when we start doing our algebraic division, that the number subtracted is a product of that particular step quotient number multiplied with the divisor that is to be subtracted. How do we subtract? By putting a negative sign, and in the end the remainder, if it's 0, well and good. If it isn't 0, it has to, how do we identify that this is where we finally stop our division? We can't go beyond this because our remainder has come smaller than the divisor. Had by mistake, like, just let's assume that had you got 51 here, 51 here, you would have still tried to get 13 3s are 39 and then subtract. But then here, as of now, our remainder is less than the divisor. So that tells us, okay, this is where we stop our division. Now with this in mind, let's learn about something else that we need to be having in mind. Degree of a polynomial is the highest degree of any of its terms. So x square plus 1, if I look at it, what is my uh, degree going to be? 1 is a constant, so the degree is 0. X square, the degree is 2. I don't go, okay, let me just put it as x square plus x. This one has a degree of 2, this one has a degree of 1. I don't say the degree of the polynomial is 2 plus 1, 3. I say that the degree of the polynomial is the degree of the highest degree which is there for any of the terms. So the highest degree is for x square, and so that becomes 2, which is the degree of the polynomial. Is that okay? So we need that in mind, because how will we establish when we finally start dividing whether our remainder is less? Well, our remainder will be less when the degree of the remainder polynomial is less than that of the divisor polynomial. So we'll get that in 2 minutes. Let's just start with this particular aspect with a small sum. So first of all, we'll start with dividing a monomial by a monomial. Remember, a monomial is nothing but a single term algebraic expression, right? Or a polynomial. So what will I do? I'll cancel all the common factors in the coefficients and also then the variable parts, right? So I've written down an example. Here this is 48 x square y square. So I'm just going to write it as a fraction. 48, I'll just split this slightly so that it is easier to understand. I'll write the numerical part under the numerical part, the x part under the x part, and the y part under the y part, right? Now, it's very clear that 48 and 9 are having at least one common factor, and that is 3. I divide 48 by 3, what do I get? I get a 16. I divide this, I get 3, right? Now, you've also learned in your exponents, when you divide numbers which have the same power. Like suppose I say x raised to power n divide by x raised to power n. It is nothing but x raised to power m minus n. So here when I write this as x, it's actually x raised to power 1. So x raised to power 2 divide by x raised to power 1. I'm actually going to get x raised to power 2 minus 1. And so that is just going to leave me with an x raised to power 1. Y divide by y, that's going to leave you with nothing. And so your final answer is 16 by 3. That comes from the numerical part. 16 by 3 is what you had got from the numerical part. From the x's, you got an x which is left. X raised to power 1, remember, is nothing but x. And the y's have cancelled. So this is your answer for your first particular question. Right? So this is how you divide a monomial by a monomial. The second thing that we could think of, and this is when you've written this in terms of a fraction, and simply cut the common factors from the numerator and the denominator. Suppose I give you a binomial by a monomial. That can also be achieved in a similar manner. Let me give you an example of 16x square y plus 4xy to be divided by, say, 2xy. That's the first term here is a binomial. This is a monomial. Remember, even when we are doing multiplication, what we were doing was we were splitting it up. So I'm going to write this as 16x square y to be divided by 2xy. And also, what's my sign in the middle? It is plus. So plus 4xy divided by 2xy. Did you understand what I've done? I split the binomial into two parts and I've kept the sign along with the second part. So 16x square divided by 2xy and plus 4xy divided by 2xy. Let's see what's going to happen here. As I told you, I'm going to write the numerical upon numerical, x's upon x's and y's upon y's. So this is going to give you 16x squared y upon 2xy, and the second term is then going to be 4xy upon 2xy. The x and the x cancel. Let me use a different color pen. Okay. The y and the y also cancel. The 4 and the 2 cancel to give you just a 2. Right? Here, in the first term, the y and the y cancel. 16 and 2 have a common factor, and that is 8. Sorry, 2, and so you get 8. X square and x common base being divided, the powers are going to be subtracted. So, x raised to power 2 minus x raised to power 1 is finally going to give you only an x raised to power 1. So, your final answer then is going to be 8x raised to power 1. Remember, whenever there is a 1, you do not need to write it specifically. So, this is 8x. All the other things have cancelled. From here, what is left is only plus 2. Is that okay? So, this is how you're going to be doing a binomial by a monomial, and this again is in the form of a fraction, cancelling all common factors from the numerator and the denominator. Hereafter, we are going to try and approach long division, right? So, the third method, as I was saying, is by long division, and this is used when the number of terms is more. You could be having a binomial in the divisor, you could be having binomial, trinomial, or even something more in your dividend. So, there are a few things that need to be kept in mind, and these are notes which you need to write down. Now, the polynomials have to be written in decreasing order of degrees. So, polynomials, both the polynomials if some power is missing in the middle, like if I had an x square term, did I have an x term? So, if some power is missing between the highest power and the lowest power, or in fact I will call it degree so that you do not confuse the terms, highest degree and the lowest degree of the dividend zero coefficient terms of that degree will be introduced. So, in this example, the divisor then will be would be 15x squared plus 0x, because I did not have an x term in my divisor. I needed to put a 0 coefficient term of the degree which was missing. So, 0x minus 6. Is that okay? Now, do I have all the terms from the highest to the lowest? This is a 0 degree term. X raised to power 0 is 1. X raised to power 1. X raised to power 2. So, my divisor here then becomes, dividend here becomes 15x square plus 0x minus 6, right? And as we did, I told you while we were revising division, three things, that how we're going to get the product. We're going to get the product by multiplying the digit of the quotient with the digit with the divisor. I'm going to subtract whatever it is by changing the sign, and in each step I am going to try and reduce the dividend terms so that in the end I am heading towards the remainder. The remainder has to be lesser than the divisor. Now, the third thing here, the remainder will be less than the divisor only when the degree of the remainder polynomial is either less than or equal to, I hope you are familiar with this sign, less than or equal to the degree of the divisor polynomial. Okay, I'll split this into two. Is less than the degree of the divisor polynomial or it is equal to the degree of the divisor, but numerical coefficient is less. Is a smaller number. So you have two cases. When will we consider that we reach the end of the division? Either the degree of the remainder polynomial is less than that of the divisor polynomial, or it can be the same. But then what do we have to check? That the numerical coefficient in the remainder is less than that of the divisor. So these are the things that you need to keep in mind when we start the division. And hereafter we are going to be taking this example on a fresh board, right? So the sum for you on the board is 15x square minus 6 by 3x minus 2. As we said, we are going to put in a 0 term. So my divisor then finally is going to be 15x square plus 0x minus 6. Also they are in decreasing order of powers, a square term, a power 1 term and a power 0 term. This needs to be divided by this particular polynomial, which is 3x minus 2. When we were doing our regular division, what did we say? That we are going to try and reduce. How are we going to try and reduce in the case of an algebraic expression? So we will reduce the highest order term. How can I get 15x square from 3x? What should I need to multiply with this divisor? What should I need to multiply in order to get a 15x square term so that I can cancel it? So if I multiply with 5x, what's going to happen? 5x into 3x is going to give me a 15x square, and when I subtract, that term will go. So this is how I am able to find out what is my term in the quotient polynomial going to be. Again, I need to try and remove this particular term, because at each step I am trying to make my dividend smaller. So if I have to try and make it smaller, I will have to get rid of this term. And I also know whatever is written here is the product of the quotient and the divisor. I already have my divisor here, and I also have this term in my dividend. So what should I multiply 3x with in order to get 15x square? Obviously it is going to be 5x. But that 5x has to be multiplied not just with part of the divisor, it will have to be multiplied with the whole divisor. So 5x into 3x is going to give you a 15x square. 5x into a minus 2 is going to give you a minus 10x. Please remember, you have to write the x square terms under the x square terms and the x terms under the x column. Now that is why now you will understand why we had to put in a 0x term, because 5x into a minus 2 is giving you a minus 10x. I could not have written it here under the constant. I need to write it here in the x column. So I write this as minus 10x, right? There was also another thing that you need to subtract whatever is the product here. So for subtracting, I changed, this was a plus sign. As of now, I change it, it becomes minus. When I put a minus of a minus, because I'm subtracting this, I will have to use a plus sign. Is that okay? How I got the minus and the plus sign? Because I'm subtracting this whole thing. This plus 15x square became a minus, and this minus 10x actually became a plus 10x. So this cancels out. Plus 0x and a plus 10x give you a 10x, and they give you a minus 6. Is that okay? Now, what did I tell you? How do you identify whether the remainder has been achieved? There were two things. Either the degree has to be lesser. The degree is the same. The degree is the same, but then what was the thing? If the degree is the same, the numerical coefficient has to be less. Here the numerical coefficient is 10. Here the numerical coefficient is 3. It is not less. So that means we have not reached the remainder. We still need to do something. Now what should I multiply with 3x in order to give me a